chord. Okay, the first problem is the same old problem. Send circle with center 1,2, radius 5 and a point outside minus 24,27. Foot of altitude from M on the tangent, that is point of contact, is B and C. Okay, so we get a kite here. BMCP is a kite. The first thing we should do now is find distance PB. This is called length of tangent. PB or PC, both are going to be equal. So find PB is the first problem. Find area Pbmc. Area of quadrilateral Pbmc is the second problem. And maybe the third problem is find area of PBC. Okay. Now, finding PB. Is it going to be very simple? Because we know that it is 90 degree here. This distance 5, radius is 5. If we find out distance between M and P, I think we should get by Pythagoras theorem distance PB. Okay, so distance PM, change color. Distance PM is equal to PM square is equal to 1 minus 24, that is 25 square, plus 25 minus 25 square. Is it correct? So 25 root 2 is PM. Yes or no?
Yes, sir.
Yes, sir.
And therefore 25 root 2 square minus 25 is equal to PB square. And if you do this calculation, you will get PB is equal to 30. That is the easiest way to do it. As far as finding out area of Pbmc is concerned, this is again right angle triangle. So area of Pbm is equal to 35 into 5 upon 2. And therefore area of Pbmc is equal to 35 into 5. But as far as finding area of PBC is concerned, we have to deal with this situation. This is root 2, 25. This is 30. I mean, we need to do it geometrically instead of doing it coordinate geometrically. By the way, I will tell you how to find out area of triangle if all the three vertices are given. Given means their coordinates are given very quickly. You also can find it out otherwise. Now, how do you find out area of, let us find out area of BTP. Area of BTP upon area of
लैपटॉप की बैटरी कमी है नहीं खेला ना
MBP. Area of BTP upon area of MBP is going to be equal to K square. What is the ratio of these two similar triangles of their corresponding sides? The smaller triangle has hypotenuse 35 and the bigger triangle has hypotenuse 25 root 2 square is equal to, so BTP upon, and we have found out PBM is 175 upon 2. This implies area of BTP is equal to, do this calculation. I mean, first of all, you can reduce this. 5 25, 35, so 49 upon 50 into 175 upon 2. Am I correct? I think so. This is equal to, this becomes 10, this becomes 5 3 15, so 5 5 25, 35 गुणिले 49 into 35, 0, 9 3 27 7, 8 2, 4 1 12 13 14, 9 5 45 5, 8 4, 5 20 आणि 4 24, 5 7 आणि 4 अगदी 1 8 नाही 7, 1715 divided by 20. That is the area of BTP, and therefore area of PBC is equal to 2 times this. Therefore 1715 upon 10. Hey, अजून further I can reduce it. Yes or no? मी 5 नाही का I should have done it by 25. Okay, so 5, 5 3 15, so 5 20, 5 3 15. Yes, somebody had shown this answer. This is the answer for this. 343 upon 2. Pbmc is 170. Distance PB is 25. Easy? Okay. Now let us do it let us do it little interestingly. I mean, solving it for numerical is always.
Sir, PBC will be the twice. It must be 343. PDC च्या दुप्पट पाहिजे.
नाही रे, पीडीसी ला इथे मी डबल केलं ना, 1715.20 into 2 केला ना इथे.
Okay, sir.
Question. Circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0. Point is x1, y1, that is p1. Okay, so same situation. Circle is given to you and a point is given to you. Point is given to you. Now you are supposed to find out distance PB, find PB, find P1, B, C. Yes. This is now going to be general. If you do exactly same way, find out distance between M and P1, that is your hypotenuse, find out radius MB, and applying Pythagoras theorem, you will get the distance P1B, which is length of tangent, and it happens to be P1B square happens to be, put this point in this equation, LHS, x1 square plus y1 square plus 2gx1 plus 2fy1 plus, this is length of tangent. So if we are calling this circle as S, then we call this as S1, because I am putting the point P1 in X1. So normally this is called S1, and therefore length P1B is root S1. Root S1 means whatever point is given to you, you put it in the equation of circle directly. That is how you should remember it, and it will be like that. So this is root S1. So this is root S1. This is R, and this is the distance MP. And we are supposed to find out this distance T and find out area of BCP. BCP1 will exactly. Now can you do that in terms of S1 and R? Then it is easy to remember. I mean, that is the formula that you will get, which will look complicated but easy to remember. Can you express your area P1BC in terms of S1 and R? I can help you out because we have got this distances here. BTP upon MBP is 35 was our root S1 and 25 root 2 was our MP. Correct? Can we call something to that MP? Okay, let it be MP. So this is equal to area of BTP square of this is BTP upon this was 175 by 2, which is root of S1 into R upon 2. MP can be written as root S1 square plus R square. MP square can be written. Okay, so I am taking this here and solving it. Area BTP is equal to S1, root S1 square is S1 upon MP square is R square S1. No, sorry. MP square is R square plus S1 into root S1 into R upon 2. Okay. Right. So what is this? S1 raised to 3 by 2 into R upon R square plus S1 into upon 2, but if I write it as area of BCP, then that 2 will get cancelled. This is what is the area. अरे समझते का सगळ्यांना? Whatever you have done is correct, but I am trying to write that area in terms of R and S1. But case to case basis, using numericals, Pythagoras theorem, you can find out those areas. That is one part of the story. And you may find problems on this, which you should solve and practice. If we get some time in the end, we will solve some problems. Let me give you another problem now, because we are discussing tangents to circle. Now let us discuss tangent to parabola, because we have learned parabola also, which is y is equal to ax square plus bx plus c. That kind of curve is parabola, opening up or opening down. So question, I have a parabola y is equal to x square, simple, and point P is on parabola 3, 9. See, now when it was circle and you were given equation of circle and you were given a point of the circle, finding tangent at that point was relatively easy because circle is a very good geometry. and radius segment is perpendicular to tangent. This information was available when tangent to circle is concerned. Now I am asking you that there is a parabola y is equal to x square and you have a point somewhere here. Find equation of tangent at P. 2y is equal to x square. सांगा काय उत्तर येते तुमचं सांगा. In case of circle, it was radius segment which is perpendicular to tangent at point of contact was useful, but that was a special property of circle, therefore we could find out tangent using that. But then for any other curve, if I want to find out tangent, then it is going to be difficult. So what do I do now? I go by my standard method when I was not aware what kind of tangent it is. So this is 3, 9. And this parabola is y is equal to x square, correct? There will exist a tangent like this. At this point, let the slope of tangent be m. Then equation of tangent will become y. If the slope is m, mx minus y is equal to 3m minus 9. That is the equation of tangent. Yes or no? Mx minus y means slope is m. Putting this point in LHS, I get RHS. That is the equation of tangent, which I can write as y is equal to mx minus 3 plus 9. Mx minus 3m plus 9. Are you there up to this point? This is the, still we have not find out the slope yet, but we have got equation looking like this, which is supposed to be tangent. Now if I solve this tangent simultaneously with y is equal to x square, I should get quadratic equation in x. I should get quadratic equation. Is that right? What I am saying is correct. I should solve these two simultaneously, and when I am solving that simultaneously, I should get discriminant equal to 0, because I am expected to get the point of intersection coincident. So solving these two simultaneously is very easy. That is why I can subtract something so that I get this equation: x square minus mx plus 3m minus 9 is equal to 0. This is quadratic in x. And I want both the roots same. I don't want two different x coordinates. I want both the x coordinates to be same. Therefore, this must be perfect square. So for this to be perfect square, delta should be equal to 0. And therefore, what is delta of this equation? M square minus 4 times 3m minus 9. Is that right? Therefore, this gives me, this is going to be perfect square. And otherwise, there is going to be a geometric problem in perfect square. And that is another cross check whether your calculations are correct or not. It is going to be perfect square. So this is perfect square of m minus 6 is equal to 0. Therefore, m is equal to 6. By putting this value of m back into this equation, we get equation of tangent. And equation of tangent is 6x minus y is equal to 18 minus 9 is equal to 9. You can cross check whether this point is on this line or not. 18 minus 9 is 9. Yes. So this is more versatile method of finding out tangent because we are not dependent on any special property of the curve. We are depending on the theory of quadratic equation. Theory of quadratic equation. Coincident roots, geometry says it is tangent. That is what we have done. We assumed some slope and we said we want coincident roots. So solved simultaneously and got coincident roots. For m is equal to 6, you will get both the values of x. If you put 6 over here, you will get value of x is equal to 3. Let us check. X square minus 6x plus 9 is equal to 0. So x minus 3 bracket square is equal to 0. Therefore x is equal to 3. So x is equal to 3 is the point where coincident tangents are supposed to be found, which we are actually taking it from here only, and hence we got it. Arey, samajhte ka? I am aware I am doing it little fast, but it is easy. Okay. Next numerical is, let me give you parabola and give you a point. Parabola is question. Change the ink. Question. Parabola P is y is equal to x square plus 4x plus 7. And point on parabola is minus 1 comma 4. Find tangent. Let me solve it quickly now. Let slope be m. Therefore, equation of tangent be mx minus y is equal to minus x minus 4. Y is equal to x plus y is equal to mx plus m plus 4. Solving simultaneously with this, we get x square plus 4x plus 7 minus mx minus m minus 4 is equal to 0. So x square plus 4 minus m times x plus 3 minus m is equal to 0. So delta is equal to square of this 16 minus 8m plus m square minus 12 plus 4m should be equal to 0. That makes it m square minus 2m 4m plus 4 is equal to 0. That makes it m is equal to 2. Therefore, equation of tangent is y is equal to 2x plus 6. Question. Y is equal to x square plus 6x minus 8. Find the equation. Equation or equations of tangents y is equal to x square plus 6x minus 8 passing through P are passing through A, 5 comma minus 2. Hopefully 5 comma minus 2 is not on this. 25. So okay. This is the point which is not on parabola. So I am now giving you something like this. A is sitting outside, 5 comma minus 2. And parabola, this is this parabola. Find the equation of tangent oblique tangents. So if the point is away, I am sure there will be two tangents like this. And hopefully the numbers are going to be good if you are lucky. If I have made some mistake while doing calculations, and if you start getting bad numbers, you report it to me immediately. Don't waste much time. Thank you. Now theory is going to be exactly same. Let m be the slope of one of the tangents. Therefore, equation of tangent will be mx minus y. It passes through 5 comma minus 2. Therefore, minus 5m plus 2. That gives us y is equal to mx plus 5m minus 2. Solving simultaneously with this, we get x square plus 6 minus mx minus 8 minus 8 plus 2. So minus 6 minus 5m is equal to 0. Right? And now we want discriminant of this.
तर ते प्लस 5m पाहिजे ना.
Yes, sir.
Plus 5m.
Y is equal to
y equal to mx minus 5m minus 2.
mx, y is equal to mx.
फर्स्ट स्टेप मध्ये तिथे -5m नाही पाहिजे.
इथे का?
Yes, sir.
Yes, sir.
5m का? हाँ 5m plus
Okay.
5. Okay. And therefore here it should be minus. Therefore here it should be plus. Is this correct now? Yes. So delta of this is equal to 36 minus 12m plus m square minus plus 24 minus 20m is equal to 0. Therefore m square minus 32m plus 60 equal to 0. Is this good quadratic? I think so.
Yes, sir. 30 and 2 are there.
Yes, 30 and 2.
M minus 2. So for two values of m, we are getting coincident roots. Earlier, because the point was on the parabola, we were surprised. How come this is perfect square? How come earlier is perfect square? Because the point was on parabola. Now the point is away from parabola, you get two different slopes, and both of them will make this quadratic equation perfect square. Let us check that. Okay, so if we put m, so now we are not required to find out put of perpendiculars, but that is additional thing which I can show you now, which we can get by putting these values of m back into the equation. However, let us write down the equations of tangents first. If the slope is m, if the slope is 2, then equation of tangent would become y is equal to 2x minus 10 minus 2 minus 12, or and sorry, not or, and y is equal to 30x 150. Okay, now let us put this value of m back in this quadratic equation. What do I get? If I put m is equal to 2, I get x square plus 4x plus 4 is equal to 0. That means x is equal to minus 2. That is one coordinate of the point of coordinate, and you put this either in your equation of tangent that you got, or you put this back into the parabola, you will get y coordinate. Minus 2 if you put here, you get 4 20 minus 60. Y is equal to minus 60. So this is the point of contact for this tangent. Because slope we used here is 2. Do you understand this? These two guys are connected to each other. Now you cross check. This point is on this line. Minus 2, minus 4, minus 12 is minus 60. Everything is falling in place. If you put 30 here, what do we get? X square minus 24x and 144. Is that right? Is equal to 0. So x is equal to 12. If x is equal to 12, 144 plus 12 6 216 वजा 8 208. Y is equal to x is equal to 12, y is equal to 208. This is another point of contact of this tangent. This is very interesting. Next question. Now I have explained the procedure also. Therefore, each one of you should get the answer. Parabola is y is equal to x square plus 2x. And the point outside is 1 comma minus 1. Find tangents. Whatever. I mean, you may not be able to draw them geometrically, but they will exist. Something like this. Kada. Find the equations of tangents and find the coordinates of point of contact. This question. Can somebody tell me the answers? What are the equations of tangents? Tangent 1.
8x plus y equal to 9.
And what is the point of contact for this?
Sir, it is not coming perfect square.
What? What is not coming perfect square?
The quadratic in x.
Right? So the
think, sir, I think it should be
Sir,
8x minus y is equal to.
Yes, sir. 8x
Yes, sir.
minus 1.
8x minus.
8x minus y is equal to, it has to be perfect square, or else.
so 3 and 15, 3 comma 15.
Here,
Minus 1 comma minus 1.
these are the answers. Okay. Now, that is what I am trying to say. It does not matter what this curve is. Suppose tomorrow you have some equation of ellipse looking like this, which is bad equation. Ellipse which is not horizontal or vertical, in 12th standard also these are going to be bad equations. This is relatively good, this is relatively good. But we are not worried about what kind of equation and how the geometry of the curve is. We adopt this procedure. If the point is given outside and if degree 2 curve is given, we do not know the nature of degree 2 curve, how it looks like. We need not have to draw geometry, but this theory will work. That is the power of this theory. Understood? So, I may give you a familiar curve, or I may give you a curve which is not familiar to you. Like say I give ellipse x square by 25 plus y square by 16 is equal to 1. Suppose this is the curve, and if I give you some point 0, 10, find the equations of tangents. Now, in this case, they are going to be bad because I have not designed it, but the procedure is same. Let the slope be n, let the equation in terms of m be so and so. Solve that with simultaneously with this in x, make discriminant 0, get two values of m, put them back into the equation of x to get two values of x. Those are the point of contact, those are the points of, those are the slopes of the lines. You get T1, T2, point of contact, point of contact. Exactly same procedure, does not matter what curve you are talking about. Okay, so therefore, and if you apply this procedure for your even circle, you will get the same result. However, circle is relatively easier because there is one more method. Radius segment is perpendicular. M1, M2 is equal to -1 is easy method for circle. Therefore, we don't adopt this for circle. But if you really decide to use this for circle as well, you will get exactly the same tangents. Tangents will not be different. Okay. Now there is one more thing that I need to tell you is shift of origin. I think I have spelled this out many times in the class. Shift of origin. As the name suggests. Now, suppose I have XY system, 0, 0 is my origin, and there is a point P whose coordinates are say 10, 6. Okay. Now, if I take origin to say 3, 1, and my x-axis will be parallel to original x-axis, new x-axis. This is x dash, this is x, this is y, this is y dash. Okay, and y dash is also, sorry, y dash tikde kute, y dash is here. Again parallel to origin. I am not rotating, I am keeping the axis parallel, but instead of origin here, I say origin is here now. The coordinates of new origin, coordinates of the point where new origin is, old coordinates are 3, 1. So okay, now let me notation. This is 3, 1, old code, old coordinates. What are the new coordinates of this point? Red, 0, 0. Do you understand the notation? Old coordinate,
Yes, sir.
old coordinates of new origin is 3, 1. New coordinates of new origin 0, 0. So now can you tell me new coordinates of P?
Sir, 7,5.
सगळ्यांनी विचार करा. New coordinates of this point should be, now 3 distance this side it has already come, so remaining distance is 7. 1 distance already gone up, remaining distance 5. Okay, next question. New coordinates of point Q is, it is below. New coordinates of point Q is 5, 5, comma -3. What is its old coordinate? Eight, comma -2. Are you there? 8, comma.
Yes, sir.
Good. If old coordinate of point R is x comma y. What is the new coordinate of R? Simple. X minus 3 comma y minus 1. अरे समझते? If new coordinates of S, capital X comma capital Y, then its old coordinates are x plus 3, y plus 1. Correct? Now, twist in the tail. Origin is shifted to h comma k. Point A in old coordinate system was x comma y, and in new coordinate system it is x comma y. How this x is related to this, and how this y is related to this y. Write down and show it to me. What is the origin shifted to? H comma k. Okay, now h comma k should be in blue. Correct? Okay. Can you tell me the relation now? What is capital X and what is small x? Is it absolutely simple? Yeah, mind well, it is absolutely simple right now on the board. But this is the most difficult thing, and many students in 12th standard IIT exam will commit mistake. Therefore, you have to be very sure about the concept, and you should take the concept along every time and write down what is your equation and how are you supposed to deal with it. Otherwise, if you remember the formulae, then it is going to be difficult. However, what is the formulae? If I want to write down capital X, now let me use black so that capital X is equal to small x minus h. Capital Y is equal to small y minus k, or capital small x is equal to capital X plus h. Small y is equal to capital Y plus k. This is important. Moreover, now let me ask you a question in this. Instead of h comma k, I am again back in 3 comma 1 system. In 3 comma 1, when origin is shifted to 3 comma 1, the original equation of straight line in this was x minus y is equal plus 5 is equal to 0. There was a straight line in XY plane when origin was here and it was looking like this. Now origin is shifted to 3 comma 1. How will the algebraic equation of line look like? This is a good question. You can tell me how the line will look like if the origin is shifted to 3 comma 1. Okay. Majority of the students for this question will give answer x minus y plus 3 is equal to 0. Most popular wrong answer. Okay, we do not know how to deal with this. Therefore, we go back to basics. Can we find out one point on this line? Yes, 0, 5. What are its new coordinates? If origin is shifted to 3, 1, minus 3, 4. Can we find out one more point? Yes, 2, 7. What are its new coordinates? Minus 1, 6. Can we find out equation of line with these two new coordinates? It is x minus y plus 7 is equal to 0. So the correct answer is x minus y plus 7 is equal to 0. Out of 35 students, one student got this, and 30, let us say 30 students got this. 3-4 students must not have done it. Why did we make this mistake? Therefore, this notation is important. This notation is important. When we are dealing with old system, we are using small x and small y. When you are dealing with new system, it is capital X and capital Y. X minus y plus 5 is equation of line in old system. And you want equation of line in new system. Therefore, you should replace x by this capital X plus 3. That is the capital X plus 3 is the value of old x minus capital Y plus 1 is the value of old y, small y, plus 5 is equal to 0. That makes it capital X minus capital Y plus 3 minus 1, 2 plus 5 minus plus 7 is equal to 0. That is what is the correct equation, because you need to distinguish between these two. This was old x, this is new x. Now, if I change this question and ask you the equation of line in a new system, is 5x plus 2y minus 3 is equal to 0. What is equation of line in old system? Okay, if I ask you this question, then what you are supposed to do is, oh, this equation is given like this, but it is actually 5 capital X plus 2 capital Y minus 3 is equal to 0. And I am asked about old system, so I am supposed to report in small x and small y. We are supposed to use. So the answer is going to be 5 inside bracket x minus 3 plus 2 inside bracket y minus 1 minus 3 is equal to 0. That makes it 5x plus 2y minus 15 minus 2 minus 3 is equal to 0. Makes it 5x plus 2y minus 20 is equal to 0. This is the old line. When converted into shift of origin to 3, 1 becomes this. Let me know whether you have understood. Resume recording. Okay. Equation of circle in old coordinate system before shifting origin was x square plus y square minus 6x minus 2y minus 5 is equal to 0. What is the equation of circle when origin is shifted to 3, 1?